Hey guys, and welcome back to the observatory. In today's video, we're going to be talking about the big telescope here and why it's been out of commission for so long and what we've done to bring it back online. So there's been three main issues with this telescope. One, the collimation wasn't very good. Two, we didn't have the telescope tracking properly. And three, the dome did not follow the telescope as it tracked throughout the night sky. And so to alleviate these issues, we've been working really hard over the past 6 months to get it all dialed in. The first part of that was getting the collimation improved. We adjusted this mirror here, we adjusted the mirror inside the tube here, and over time we just got them as close to aligned as we could. They probably need to get aligned even better than they are, but we're going to get that figured out here in the next few months once we start looking at stars and are able to really start tracking it. Secondly, we had to get the improved tracking system for the telescope figured out. So we have these motors on the telescope down here. The old motors, which look very similar to this, but they were gold. They were made by a company called Pittman, and they were about 25 years old. So they were totally useless at this point. They weren't tracking properly. They were jittering back and forth. And so it was not good enough at all for taking photos. Good enough to look through the scope visually, but when you want to take pictures of things with a long exposure, it has to be very precise and not jumping around. So these new motors here are not only gonna be much higher resolution and much finer detail in what they can produce, but it's gonna be much smoother without any mechanical issues going on. We also swapped out the motor down here, which is the right ascension motor. So now both axes are switched over to these brand new high resolution motors. Going to be much better than the old ones we had previously working. So not only is this telescope controlled by a computer that is accessed anywhere on our observatory network, but we also have a hand controller that looks just like this that I can push left, right, up, or down to move the telescope. So when we go up and down, it's going to move this motor here, and the telescope's going to go up and down in relation to the equator of the Earth. And then we can also move the telescope in left to right direction like the Earth spins, which looks like this. And the final problem we had at the observatory was solved by this little box right here. Inside here is a printed circuit board made by a company called Diffraction Limited, and this is called the Max Dome 2. This is an observatory dome control system that allows you to interface with ASCOM, a motor that is driven by either DC or AC power, and it can control the dome and say, move left or right according to how the telescope is moving. It is able to track the direction and position of the dome using this black and white strip that is painted onto this wheel, as well as a small infrared sensor that we've attached to this motor. So as the dome spins left and right, this counts up and down in the ticks of black and white. So at this point, we now have a telescope that tracks, is mostly collimated, and also has a dome that is able to follow it wherever it goes. The only things we have to do now is create a good pointing model, get auto guiding working, and take calibration frames for our new system and make sure everything is working, and then we'll be off to the races with our new setup. I'm really excited to have this telescope finally taking the amazing pictures we all know that it's capable of doing. So if you're excited to see those photos, as well as to see what else we're going to be doing on this telescope, make sure you're subscribed. And if you didn't already like this video, please do that. And I will see you guys in the next one. Peace.